So welcome to another video on bearing. Today we'll be looking at real problems on bearing. We've discussed a lot about bearing. We've seen what bearing is, types of bearing, reverse bearing. We've even talked about cosine and sine rule. And I think these are the things we've discussed, but this time we're going to be applying all the things we've learned in today's video. So the first question is, Jade starts a 3 kilometer walk from X and on a bearing 0 to 3 degrees. She then walks 4 kilometers on a bearing 113 degrees to Y. What is the bearing of Y from X? So like you would have noticed, in bearing we will represent our question with a diagram. That helps us to understand what method we're going to use to solve. Okay, so let's do that. So J starts a 3 kilometer walk from X on a bearing 0 to 3 degrees. So I want to do that on another page. So this is Jade here, right? So she works 3 kilometers on a bearing of 23 degrees. So this is 23 degrees on the first quadrant, right? So she walks 3 kilometers on this. Okay, this is 3 kilometers. This is 23 degrees. It's 23 degrees. Okay, and the question says, if you go back to the question, she then works 4 kilometers. So now she changes course because the bearing of the 4 kilometers changes to 113 degrees to Y. So she then works 4 kilometers on the bearing 113 to Y. So she gets to this point and works on a bearing of 113 degrees. So the bearing of 113 degrees, if you have the coordinates like this, it's going to be on the second quadrant. Okay, so this is bearing of X. Okay, so it's going to be in the second quadrant. So you draw another line here to Y. So this will be Y. Okay, and this is 113 degrees. On 3 degrees. Okay, so now the question is, let's go to question, what is the bearing of Y from X? Now let's see, they want to know what the bearing from Y to X is. They want to know the bearing of Y from X. Let's see, of Y from X. So basically they're asking you to find this bearing. Let me use another color. So they're asking you to find the bearing that connects. So this is the bearing of. Let me go back to this color. Sorry. So this is the point that connects X to Y. Okay. But to be able to get the bearing of Y from X, they're asking you to find the angle that forms this connection. So from here to this point, right? So this is the bearing they want you to look for. Okay, so how would you do that? So there are a lot of ways to do this, but the first thing we're going to do is to find the internal angle, meaning that we're going to look for this side first. We already know what this is, 23 degrees, right? So if we know this, let's call it theta, and add it to 23 degrees, we'll be able to get the bearing of Y from X. Okay, so now that we know that it's theta we're looking for, what are we going to do to find the value of theta? So I forgot to put this 4 kilometers here. Okay, so what method are we going to use? Now, if you notice very well, we cannot use the sine rule. Yeah, because we just have one angle here, one unknown angle here, and if we look for another angle, possibly here or here, we possibly will not find it since we do not have any other angle known. Now we cannot also use the cosine rule because we just have an unknown angle and just two sides. Okay. Most times we use the cosine rule in bearing to look for the distance. Maybe if we're asked to look for the distance from x to y, we use the cosine rule. Okay. So and most times we use the sine rule to find the bearing. But looking at this, we cannot look for the bearing using the sine rule. Remember the conditions for applying sine rule is when we have two sides and possibly two angles here. So one unknown angle and one obvious angle here. So but we do not have that here. But what other method can we use? We can actually use a secateurs. Okay? But we normally use a secateurs when the triangle is a right angle triangle. So is this triangle a right angle triangle? Well, let's find out. So let's find out the included angle here to see if this is a right angle triangle. Okay, so the angle that is formed from 3 kilometers and 4 kilometers will tell us if this is a right angle triangle. So tell us if we can use the secateurs or not. But most times we'll need this angle, this included angle here, when applying cosine rule to find distance. We'll be doing that in another video or another example. Let's call this part R and let's call this part P. For us to be able to find this angle, we need R and we need P. So R plus P will give us the desired angle. But what is R first? R will be 23 degrees. Okay, so I know this looks like 25. Let me just correct something. This looks like 25. But let me correct that. This is actually 23 degrees. Okay, so why do we say R is 23 degrees? Now, if you look at it, the diagram, it looks more like this. Let me use another color. It looks more like this. So this is 23 degrees. Okay, and based on your knowledge of angles, 23 degrees is alternate to this, which is R. So we can say R is 23 degrees. Okay, so we can say R is 23 degrees here. I'm having a problem with my pen. Okay, but what about P? How can we get P? Well, if you notice also, we have 113 degrees, the bearing that gives us the direction to y. And from 113, from this point, let me use this color, okay? From this point to this point is 180 degrees, okay? But we have just 113 degrees at that point. So the point that completes 180 degrees is P. So that means P plus 113 will give you 180 degrees. So you can just say that angle on a straight line is equals to 180 degrees. And P and 113 are on a straight line. If you want to see that clearly, it looks like this. So P is actually here. and 113. No. Okay, P is actually here. 113 is actually here. Okay, so since the angle on the straight line 113 and P, then P plus 113 equal to 180. Okay, so when we bring 113 to this other side, we get the value for P. So that means we can say that P is equal to 180 minus 113, which is actually 67 degrees. We know that arrow is 67. We know that arrow is 23 degrees. So this whole angle here is 23 plus 67, which is equal to what? 90 degrees. So it's obviously a right angle triangle. So we can easily use the SOHCAHTOA, like legally. So, but basically, it's important you always find this angle that is formed from the two sides. So now that we know this, we can use the SOHCAHTOA to find theta, this theta here. Okay? So we have here as opposite to the angle, desired angle. We have here as the adjacent. So opposite over adjacent will give you tan theta. So that means we can say tan theta, remember it's theta we're looking for first before the bearing, is equal to 4 over 3. So tan theta is equal to 1.33, and theta will be equal to the inverse of tan, 1.33, and then your answer will be what? Let's check it. Inverse of tan, 1.33, that's obviously 53.1 degrees. Okay. So now that we know our answer is 53.1 degrees, what is our bearing? We said our bearing is a point from north to this point here. So we know what theta is, and we know what this other point is, 23 degrees. So our bearing is going to be what? We can say our bearing is equal to theta plus 23 degrees. That means it's equal to 53.1 plus 23. So that is equal to 76.1 degrees. So we can say 076.1 degrees. Okay. So this is the bearing. So you take note of what we did here. Naturally, we normally use the sine rule to find a bearing in this normal problems of bearing. But this time we use the SOHCAHTOA since the sine rule cannot work here. And we validated the SOHCAHTOA because we were able to find that this included angle here is 90 degrees. But most times you will need to find this included angle when finding the distance from any point using cosine rule. We'll be showing you that. I'm sure you understand this point though. Let us look at another example.